All right, this is a video on right triangle trigonometry, specifically finding missing angles in a right triangle if we know some of the sides, trying to figure out what some of the angles might be. We'll start off with a reminder of what the trig ratios are, and then we'll do 2 or 3 solved examples. So I have a triangle shown here with the vertices capital A, B, and C, and then the corresponding opposite sides are the lowercase letters. So for example, vertex A is across or opposite from side A, etc. Okay, standard way of labeling a triangle. Reminder of our trig ratios: sine of theta is opposite divided by the hypotenuse. The cosine of theta is adjacent divided by hypotenuse, and opposite and adjacent need to be legs of the triangle. The hypotenuse obviously is the hypotenuse of the triangle, and tangent of theta is opposite divided by adjacent. Please do not refer to these as sin, cos, and tan. Please refer to them as sine, cosine, and tangent. Okay. Also, theta is never the right angle in the triangle. Theta is always one of the acute angles. So theta in the triangle shown here could be angle A, could be angle B. All right. So when we're writing trig ratios, what I suggest doing first is, based on the angle you're working with, labeling what I call HOA, hypotenuse, opposite, and adjacent. So the hypotenuse is always the side across from the right angle, the longest side of the triangle. The opposite is the side that's opposite the angle you're working with, and so I'll label that O. And the adjacent is the side that's next to or adjacent to the angle you're working with, so I'll label that O, or excuse me, A. Okay, so that's what I always suggest doing first, is labeling HOA, opposite, or hypotenuse, opposite, and adjacent. That's going to be pretty critical. Let's actually apply this to finding missing angles in a triangle. As a reminder, whenever you're doing anything with right triangle trigonometry, make sure you know what mode your calculator is in. And if you want to be in degree mode, in this case we're working in degrees, so I do suggest that. Check it. You can do the sine of 30. You should get 0.5. That's a good way to check to see if you're in the right mode. So let's do this first problem here. We have a right triangle. We have a hypotenuse of 10 and a base of 6, and we don't know what theta is. Okay, we're looking for theta. We're curious. What's the measure of angle theta? It looks like it could be 30, 40 degrees. Who knows? Okay, so let's, as I said before, let's label HOA. So the hypotenuse is the longest side of the triangle. The opposite is the side opposite from the angle we're working with, and the adjacent is the side next to or adjacent to the angle we're working with. Next, let's cross off the side we don't care about. I don't know the opposite, and I don't want to know it. I don't care about it. I only care about the hypotenuse and the adjacent here. Okay, we could go back and look at our trig ratios and realize that the only trig ratio that involves the hypotenuse and the adjacent is cosine. So we'll be working with cosine for this particular problem. And we can write out the cosine of our unknown angle theta is the adjacent divided by the hypotenuse, 6 over 10. Okay, what we're actually going to do right now to get theta by itself, you might sort of think, oh, can we divide by cosine, right? Can we? No, you can't divide by cosine. Cosine's not a number. Cosine's an operation or a function, okay? So what we can do is we can undo the cosine. So let me give myself a little bit of space. And what we're actually going to do is we're going to take the inverse cosine of both sides. And that's a button on your calculator that's probably very close to the cosine button. It's probably right above the cosine button. Maybe you need to hit the second option or the shift function and then access that. But really what you want to do is, well, once we realize that this inverse cosine and this cosine cancel out, we're left with just a theta on the left side. And we want to find the inverse cosine of 6/10, which is 0.6. Okay? And so I would go to your calculator and try to find that. And I get theta is roughly 53.13 degrees. So you can check that on yours, make sure you're doing the calculator correctly. All right, Let's do this next one, angle, or problem number B, and we're looking for angle theta. And let's first label HOA, like I've been saying. So hypotenuse is the longest side opposite or across from the right angle. The opposite side is this 50, which is opposite the angle we're working with, and the 120 is adjacent to the angle we're working with. So here we're given all the sides of the triangle, and we need to think about which trig ratio we should use. Well, we're being given more information than we need, and we can actually pick a trig ratio to use, okay? We could pick any of them. I'm just gonna say, let's work with the opposite and the hypotenuse. Let's use sine, okay? So let's pretend we don't know the adjacent, and let's pretend we don't need to know the adjacent, okay? So sine uses opposite and hypotenuse. So let's write out our equation. So the sine of our unknown angle theta is equal to the opposite, which is 50 divided by 130. Okay, now we just need to solve for theta. And again, to do that, we're going to take the inverse sine, the inverse function of both sides. If we take the inverse sine of the left side, those will cancel out, leave us with just a theta. But we need to, of course, do that on the right side as well. We need to do the same thing to both sides of an equation. So here on the left side, we're just left with a theta. And on the right side, we're looking for the inverse sine of 50 over 130. Okay? So you're going to do, sometimes some calculators, you type in the 50 over 130 first, get a decimal, and then do the inverse sine of it. Some calculators, you just type in left to right. So you need to know how your calculator works. But regardless, I get an answer of theta is approximately 22.62, and this would be in degrees, okay? Theta is roughly a little bit less than 23 degrees. All right, right triangle trigonometry, finding angles. We're going to label hypotenuse, opposite, and adjacent, pick a trig ratio, and then use the inverse trig button on our calculator to solve for the angle. And that is a good place to stop.